question the student brought to us is a related race problem, where car A is driving east towards the intersection. Car B has already gone through the same intersection and is heading north. We want to know what rate is the distance between the cars changing at the instant when car A is 40 miles at the intersection and traveling at 50 miles per hour, and when car B is 30 miles at the intersection and traveling at 60 miles per hour. The problem-solving strategy we are particularly going to use for this type of problem is that of drawing a diagram. The hardest part of these problems, apart from drawing the diagrams, is determining the equations. So for here, we're going to let x be the distance between A and I, which is going to be 40 miles per hour, and we're going to let y represent the distance between car B and A and I, which is 30 miles per hour. From this, you can see the beginnings of a triangle, a right triangle, where the hypotenuse is the distance between them. This problem-solving strategy of drawing a diagram gives us the ability to, from there, derive an equation to solve this problem, which is the Pythagorean theorem.
So we can see from this diagram that the distance, we can come up with the equation distance squared is equal to x squared plus y squared. And this is kind of where Michael and I struggled on, is actually visualizing this and seeing that the distance is the hypotenuse, and it's not just, you can't just add up x and y. It's actually x squared plus y squared. You take the square root of it. So in this case, you would differentiate it implicitly, and you would get 2d dd over dt is equal to, so you differentiate it with respect to t, 2x dx over dt plus 2y dy over dt. So we have x, we have y. Well, we don't have d. D, we can see that it's just the hypotenuse, so it's equal to 50. So 40 squared plus 30 squared, take the square root of that. We don't have dx over dt and dy dt, so we can look at the question, and we can see that it is traveling at 50 miles per hour. That's the derivative of displacement with respect to time, the velocity. And it's going towards the intersection I. So we would have dx over dt is equal to negative 50, because the displacement is decreasing. And we have dy over dt is equal to 60, because it's going away, it's positive. The displacement is increasing as t increases. So we have all these values now. We can just substitute it in, and we will be able to find dd over dt. In conclusion, the hardest part of this question is actually finding this equation right here to differentiate, and we do that by drawing a motion picture diagram and visualizing it using the Pythagorean theorem. Thank you.